In section 6, we get to learn about the quadratic formula. This is probably something that you remember dealing with a little bit in Algebra 1. I know that when I taught it a few years ago, you had to use it in Algebra 1, but you didn't have to memorize it. It was kind of like an introductory thing. The quadratic formula is great because, like completing the square, it will solve any quadratic, unlike factoring or graphing. And it will also get the complex or imaginary numbers as well. In fact, the very first thing we'll see is how to find it, and we find it by completing the square. So let's look to see that. You've probably noticed that in completing the square, you do the same thing over and over and over again every time. So why not just do it once for this general case, ax squared plus bx plus c, and then plug it in. That's what we'll get with, that's how we get the quadratic formula. And so I'm going to take you through these steps. This is not something that you really need to know how to do. It gets kind of hairy in the middle because there's a lot of variables going on. But I think it's important to see where the quadratic formula actually comes from. And so, completing the square. The first step, we need to get the x squared and x by themselves so we can subtract c. And then the next thing we need for completing the square is we need the x squared to be completely by itself, not ax squared, just x squared. So we'll divide everything by a. And so the a goes away there. B divided by a is b over a. Doesn't simplify. I said it's going to get a little bit hairy in the middle. And then minus c becomes minus c over a. I left my space because we're going to complete the square here. So we're going to want our next step, because remember, we do these two steps at the same time. We'll have x plus something squared. Well, we take this b over a and divide by 2. You divide a fraction by 2, it's like multiplying by 1/2. You just multiply the denominator by 2. So we get b over 2a. Then we need to square that and add it to both sides here. So when we square it, b over 2a squared, b over 2a squared. Well, b over 2a squared, we can square the top and we can square the bottom. So we get b squared over 4a squared. There's b squared over 4a squared. And then the c over negative a, let's just move the minus out in front, so minus c over a. I switched the order there for a reason. Remember, we're developing the quadratic formula here. Mathematically, there's no reason to switch it, but we're going to see where that formula comes from. Also notice that over here, I know some people have been taking this and moving it down. This b over 2a squared is part of x plus b over 2a squared. If we multiply this out, we would get this trinomial here. So we have b squared over 4a squared minus c over a. We're going to simplify this. We can add them together. We'd need common denominators. We have an a, we have 4a squared. Need to multiply this. We need another 4 and an a. So we multiply the top by 4a. We get 4a times c. We can add them together. B squared minus 4ac over 4a squared. This part should start looking familiar if you're remembering the quadratic formula at all. Then the next step, we can square root both sides. X plus b over 2a equals plus or minus the square root of this whole mess. Notice the denominator, 4a squared. That's 2 squared and a squared. When we have a square root, we can take the square root of the top and the bottom completely separately. The top isn't going to simplify at all, but the bottom, the square root of 4a squared, is just 2a. And so we have x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. And subtract the b over 2a. to the other side. We have negative b over 2a plus or minus square root b squared minus 4ac over 2a. We're going to combine these into one fraction, but before we do, look at this negative b over 2a. Have we seen that before? If you're thinking that's the x part of the vertex, which we saw in section 2, and then continuing, that's because it is. This is the x part of the vertex plus or minus the distance to the zeros. And so that x part of the vertex comes directly out of the quadratic formula. In fact, if we look up at the top, if we moved, not at the top, but in this line, the x plus b over 2a squared equals b squared minus 4ac over 4a squared. If we moved this b squared minus 4ac over 4a squared to the other side with subtraction, we'd have vertex form. The vertex is at b over 2a, comma, well, negative b over 2a, comma, this mess, which is what we'd get if we plugged it in. Anyway, back down to the bottom. So x equals that. We have common denominators already, so to add them together, it's just negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is the quadratic formula. The question always comes up, do I have to memorize it? Well, no. You could complete the square every time, but memorizing the quadratic formula, you just plug in the numbers, and then it's just a calculator. It's a computation. I call it plug and chug. You plug in the numbers, just chug it out, and you get your answer. And the nice thing is there's no actual thinking involved in using quadratic formula. It's, computations, but you don't have to think. Whereas in something like factoring, you have to think. There's something times something. I need two things that multiply to give me something, but add to give me something else. And then if you throw a term in front of the x squared, it gets even more complicated. Quadratic formula, it's like, all right, here's a, b, c. You plug it in, a couple multiplications, subtraction, square root, and you're done. And so that is the quadratic formula. Very useful, and again, it will get every root. It'll get the complex roots, which factoring will not get. It will get irrational roots, something like 3 plus or minus root 2, which factoring will not get. But it'll get all of them, just like completing the square, because the quadratic formula is completing the square. And so in the quadratic formula, we have a piece called the discriminant. The discriminant is the stuff underneath the square root, and that'll tell us something about the answer. We could just find this piece and look to see if it's positive, negative, or 0. If it's negative, that means that there are two complex solutions and no real solutions. Because if it's negative, we're going to have the square root of a negative number, which is going to give us that I. It's going to give us that complex number. And so there's no real solutions. If we graph something where this is negative, it won't hit the x-axis. It will either be all the way above, always above it, or always below it. You cannot solve that by graphing. You cannot solve that by factoring. You have to use quadratic formula or completing the square. If it equals 0, then there's exactly one solution, and that can happen because it's actually at the vertex. If it equals 0, that means that the square root of that, square root of 0 equals 0. Negative b plus or minus 0 is just negative b over 2a. Well, x equals negative b over 2a is the vertex, or it's at the vertex. So if that equals 0, hey, there's one solution. And if it's positive, it means that there's two real solutions, because we'll have our negative b plus or minus a number. Well, a number one way, and then minus a number the other way. If this number b squared minus 4ac is a perfect square, say it's 16, the square root's 4, hey, we could have done that by factoring. If it's not a perfect square, like 1, 4, 9, 16, 25, 36, if it's not, let's say it's 10, then we're going to have square root of 10. That's an irrational number, and we wouldn't have been able to find it by factoring anyway. And so I've been talking about the methods of solving quadratics. The first way we looked at was by graphing, because we're done with our methods of solving at this point. The first way is by graphing. Graphing is great to get an estimate. It's great to check our answers, but really graphing is just guess and check. If it's anything that's not an integer, like if x equals 1, x equals 3, graphing could work. You can guess and check, and hey, look, you got it. If it was even, say, at 1.2, you're probably not going to find that by graphing. If it's irrational, you're not going to find it by graphing. If it's imaginary or complex, you definitely won't find it by graphing, because those solutions don't even have meaning in the graph. The graph is for real numbers only. The second method is by factoring. Factoring is great. It's quick and easy if it can be factored. I know people ask me all the time, well, how long do you try and factor something? And the answer is not very. If I look at it and think, I don't know, I might be able to factor, I might not be able to factor it, that's about as far as I'm thinking. I'm just going to throw it in the quadratic formula and be done with it. And so factoring is great if you can, but a lot of times you won't be able to, or even you might be able to. If we have something that starts out with 6x squared, hey, we might be able to factor that, but it's going to be a pain. Quadratic formula. Next method, by using square roots. If you have an x squared and a number with no x term, square roots. Get the x squared by itself, square root, you'll get plus or minus something. Yeah, you could factor that. Yeah, you could plug it into quadratic formula. B would be 0. And you just chunk away at that, negative 4ac over 2a, and square root, etc. But using square roots, and we'll actually see that on the next page. By completing the square, personally, I wouldn't solve it by completing the square. I would use a quadratic formula. It's the same thing. I know the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I didn't just read that. I'm looking at a sword on my wall randomly enough. But knowing the quadratic formula means you don't have to complete the square. But again, if memorization isn't your thing and you can complete the square, go ahead and complete the square. Completing the square is more useful in putting things in vertex form, and we'll see it again in chapter 10 when we're looking at conic sections. And finally, by using the quadratic formula. The quadratic formula and factoring are the two big ways, and using square roots, but that's more a special case. But the quadratic formula, it's long and obnoxious, but it's mindless. It's just computations. A calculator can do it, and it'll always get an answer. And so, using the quadratic formula is a fantastic method of solving a quadratic. So, how do we use the quadratic formula? Let's start with the quadratic. F of x equals negative 3x squared plus 4x minus 4. Are we going to be able to factor this? I don't know, negative 3, that doesn't look like it. Is it possible? Maybe, but I wouldn't try. So we always want to get it equal to 0. Again, when it's f of x equals, we make it equal to 0. If it just had x squared, like maybe this negative 4 was on the other side, we'd add and subtract to make it equal 0. And then quadratic formula. We have our a is negative 3, b is 4, c is negative 4. we have our quadratic formula. We just plug it in. All the b's turn into 4s, the a's turn into -3s, and the c turns into a -4. At this point, we just need to go 4 squared is 16. We have -4 times -3 times -4 is -48. And 2 times -3 is -6. 16 minus 48 is -32, which I'm glad we didn't try and factor this. We have the square root of a negative. It means that there's going to be an I involved. So it'll be I, 32. You can find, well, that's 16 times 2. 16 is 4 times 4. One of the 4s can make a break for it and get out. So we end up with 4 root 2 times that I. And then simplify. And when you simplify, sometimes it's easier to break it up at the plus or minus. -4 over 6, -6, plus or minus 4 over 6 root 2i. The negative in the denominator of the second one really doesn't make a difference because all it's going to do is change the sign. The plus or minus means that we have both of the signs anyway, so that negative is meaningless. But in the first one, -4 over -6, well, negative over negative is positive. 4 over 6 is 2/3, plus or minus. Again, 4 over 6, 2/3. There's another root 2 in the top and an I. So you get x equals 2 over 3 plus or minus 2 root 2i over 3. Is that an obnoxious answer? Yes, but it happens. So in this process, I showed a lot of steps. You wouldn't necessarily need to show every single one of these steps. First of all, I wouldn't write down this. Saying A equals B equals C equals is not a bad idea, especially when you have some negatives in there. It'll help make sure you have negatives where they belong in your answer. Plugging it in, you could have probably done 4 squared all in that same step. And in fact, you may have even been able to multiply all this together in the same step. We can add that and split them up at the same time. You can combine some of these steps. I was just showing every single step. All right, so let's look to see about another quadratic. Oh, so yeah, that's quadratic formula. Again, long and obnoxious, but it's just computation. There's no thinking involved like when we're factoring. Another one. F of x equals 7x squared minus 3. Hey, there's no x term. Well, in that case, instead of going through this mess, just solve using square roots. We're going to get the x squared by itself. But first, we need to turn the f of x into 0. All right, now we're going to add 3, divide by 7, and square root. So x equals plus or minus the square root of 3/7. That is essentially the answer. We just don't like having that 7 inside of a square root. Remember, a square root of a fraction is the same as the square root of the top divided by the square root of the bottom. So to get rid of that square root of 7 in the denominator, we just need to rationalize it. We multiply by root 7 over root 7. Root 3 times root 7, multiply the insides, root 21. Root 7 times root 7 doesn't go away. People try to make it just go away. It doesn't. The root goes away. So we'll get root 21 over 7. The plus or minus just follows it along, and there's our answer. We could have plugged it into the quadratic formula. The b's would have been zeros. So you would have had -4 times 7 times -3, and over 2 times 7, and it would have simplified to the exact same thing, but it would have been more of a painful process. If you see it, hey, there's no x term, look at square roots. So try one, and fx equals 3x squared minus 10x plus 3. Solve solve the quadratic. Remember, we have a few methods. You can try factoring it if you want, although 3x squared, I don't know, or quadratic formula. I wouldn't go completing the square here because the idea is practicing quadratic formula. And so it's right here for you to plug in. And pause this, push play again when you think you have it, and I'll see you then. So how was that? Well, the answers here didn't come out too bad, did they? So we'll see what it is. Plug it in. B is -10. A is 3. C is 3. So you get that. We can simplify. 10 plus or minus square root of 100 minus 36 over 6. 100 minus 36 is 64. Oh, the square root of 64 is 8. We could have done this by factoring, and I'll show you how to do that as soon as we're done with this one. Well, 10 plus or minus 8 over 6, we can actually do that. It's 10 plus 8 over 6, 10 minus 8 over 6. 10 plus 8 is 18, divided by 6 is 3. 10 minus 8 is 2, divided by 6. 2 over 6 reduces to 1 over 3. And so we get x equals 3 and x equals 1/3. If you looked at this and saw, hey, you know what? I think I can factor this. Good, because you can. How long would I have looked at it? Like, I would have probably seen that I could factor it simply because I have a lot of practice seeing this stuff. But, honestly, maybe I would have missed it. Then been thinking, I don't know, 3x and 3, I don't know, quadratic formula. But if you saw that you could factor it, we can come down here. It factors, we have 3x squared. Well, 3x times x will equal 3x squared. And what times what equals 3? -1 and 3. And so if we multiply this out, we'd have 3x times x is 3x squared. 3x times -3 is minus 9x. Then minus another x. -9x minus x is -10x. And then -1 times -3 is +3. So this would be the factors. Equals 0. We can split it up. So either 0 equals 3x minus 1 or 0 equals x minus 3. For 3x minus 1, we would add 1, divide by 3. For x minus 3, we'd add 3. And we'd get, so we add 1, divide by 3, get 1/3. Add 3, we get x equals 3. So same answers there. Notice factoring is a lot quicker and neater, but there's the thinking that goes into finding the actual factors. Sometimes it's easy, sometimes it's not easy. Quadratic formula, it's long and obnoxious, but it always works. So let's try one more. So try f of x equals x squared plus x plus 1. A, B, and C are all 1. Caution on this one. People think, oh, this is like the simplest case. Everything's 1. I'm going to factor it. Don't spend a lot of time trying to factor this because it's not going to happen. So this is definitely a quadratic formula question. So go ahead, plug it in, and see what you get. Are you glad you didn't try and factor that one? I know I would be, because when I do it, I get imaginary numbers. If you didn't get an imaginary number, go back and try it again. But if you did, let's see what we get. So we plug it in. It's a whole bunch of 1s. We can multiply. Multiplying by 1s is easy. So you just get -1 plus or minus the square root of 1 minus 4 over 2. 1 minus 4 is -3. And there's where that imaginary number comes in. The negative just comes out. The 3 is not going to simplify. So it's just I root 3. -1 plus or minus I root 3 over 2. You could leave it like that, but splitting it up like we did over here, especially when we have imaginary numbers, is ideal, simply because we like to have the real part and the imaginary part. This is mathematically correct, as good as an answer. But splitting it up also can help simplify in those cases when we can simplify. So if we were to split it up, we just have this negative 1 over 2. Then we'd have the I root 3 over 2. And I move the I to the end so that the imaginary part's right here. Like it's just another way of showing it. I'm trying to show you a bunch of different ways you can write this same exact thing. So negative 1/2 plus or minus root 3 over 2 times I. And so that's the answer. That's it. That's as far as we can go on that one. Again, I'm very glad that I didn't try to do this using factoring because it's not going to work. And I hope you got the same answer. This is the end. It's just quadratic formula. That's all it is. It's being able to use this equation and then also being able to pick which method are we using. Like here, we use square rooting. Here, we could have used factoring. But most of today, it's just going to be using quadratic formula, getting used to just that really big formula, plugging in numbers, computing it. The more times you do it, the easier it'll be to remember it. There's a song, I think it goes to Mary Had a Little Lamb. I'd sing it for you, but there's a court order keeping me from singing in front of people, so you don't want that anyway. So anyway, quadratic formula, that's all it is today. So I will see you in class. Be ready for a quick group activity, and I will see you then.